All right, guys. So make sure that you have, some a pencil and some paper to do a couple of these practice problems. Um, I'm really sorry that we had to miss math last week. It was just one of those things that came up that I could not control. So there we go. But looks like I hear some background noise, so make sure you're in a quiet place with your door closed and you're ready to go. All right. First things first, we have oops, there we go. Um, some review games with angles, and then we're going to move into circles. And then, if we have a little bit of time, we can go into probability, some of the things that you've already done, and then previewing things coming up in the future, which is polygons, so different shapes. All right, so let's go ahead and get started. We'll start with angles. Okay. Okay, we have a little lesson on angles, and we're going to have some practice problems throughout. You need to get down. I'm sorry.
Angles are everywhere.
An angle is formed by two rays with the same vertex. This sign indicates the angle we want to measure.
I'm going to pause it.
Angles in a special way.
There we go. I'm going to pause it right here. There is some vocab that I want you to be aware of. Notice this line right here with only one arrow on the end. That's called a ray. What would it be called if we did not have an angle here and we just had a line with two arrows on the end? You could type it into the chat. Would it be called a line segment? Or would it still be called a ray? Or do we know? And it's okay if you don't know. You could just type a question mark if you don't know. It's something that we'll, cover. Definitely, Jacob. We're going to get to it today. So if you don't know, just pay attention to what some of this vocab, because it makes a difference as we're working with angles and geometry. Right now, Jacob, I know you came in just maybe a minute late. We are watching a little video on angles, and it's going to give us some practice problems along the way. And then we're going to play a game with angles. So, and then we'll go on to some other concepts that you're going over. Okay, so I'm going to go ahead and restart the movie, and we'll just pick up here.
The vertex is given a letter name. Any letter will do. Let's call this one D. We can also name points on each ray. Let's call these points S and Z. This angle is called angle SDZ, and we write it like this.
I don't know why you say Z instead of Z.
Always the middle letter.
That's okay. All right.
Time can be measured in minutes. Length can be measured in centimeters, and angles are measured in units called degree. Certain angle measurements have special names.
Okay, so I'm going to pause it again. I hope you noticed that a right angle just looks like that, part of that square, and it's just a right angle like so. If it's smaller than 90 degrees, it's called an acute angle. If it's bigger than 90 degrees, it's called obtuse. And then if it's just a straight line, it's called a straight angle.
Drag the angle labels to the appropriate angle.
Okay, so this is where you're going to help me out. Let's just start with this first word, obtuse. So I guess you're probably going to have to just speak for this part and not type into the chat. You could just tell me if I'm getting hot or cold. And basically what I'm going to do is I'm going to drag obtuse to one of these blue angles. So you're going to tell me when I'm getting hot or if I'm hot or cold. Hot or cold? I don't know. Is this a obtuse angle? Am I hot or cold? Should be cold. Okay, good, Josh. Cold. That's true. I could label them by letters, but that might take a little bit too much time. Okay, good. I'm cold. Cold. And so, am I getting warmer? Hot. All right, perfect. Good job, guys. All right, a reflex angle is bigger than 180 degrees. So oh, well, I don't want to give it away. I'm going to come back to this one. Let's go to right angle. Right angles are pretty easy. Hot or cold? Looks like we're typing into the chat either hot or cold. Yes, cold. Good. Hot or cold? You could even just type a C. Good. What about this one? Hot. Perfect. Good job, guys. Okay, an acute angle is smaller than 90 degrees. Hot or cold? Good. What about this one? Cold. Okay, good. So then that just leaves a couple other options. So let's see. Oh, there we go. Smaller than 90 degrees. Perfect. Okay, a straight angle. That is super easy. We're just going to go ahead and put it on there. Straight angle. It measures 180 degrees. Okay. So that little red angle is 180 degrees. That's half of a circle, by the way. A full circle would be 360, right? 180 plus 180. Just a little side note. So a reflex angle, it's always shown. Excellent. Okay. It's always shown right there with bigger than 180 degrees.
Sometimes we need exact measurements of angles. For example, architects and builders need to be precise in their measurements of angles. We can measure angles with a special tool called a protractor. Having two scales on a protractor makes it easier to read an angle measurement, depending on how the angle is positioned. To use a protractor correctly, you need to place the center mark on the protractor on the vertex of an angle. Follow these easy steps to learn how to use a protractor correctly.
Okay, so now I'm going to have to, oh, there we go. Turn the protractor until the 0 degree line is right there along this bottom line of the protractor. So notice the center of the protractor is on the vertex, and then that bottom line lines up with the angle on the bottom. So then all you need to do is just follow along this other line and see where there we go. Got a little bit bigger, and see where it falls on the protractor. So just look at the angle itself. You can see that it's on the 40-degree line or 140 degrees. And since we know that this is an acute angle, we know that it's the 40-degree angle.
We can simulate the use of a protractor on your computer.
All right, here we go. Okay, so it's just telling me how I'm going to use my protractor.
Now it's your turn. Use the virtual protractor to measure the following angles. Choose the correct answer from the choices that are given.
Okay, before I even start messing around with this protractor, what type of angle is this? Go ahead and type into the chat the category, the type of angle it is. Is it a straight angle, reflex angle, obtuse, or acute? It would actually be acute. Acute means smaller than 90 degrees, okay? And you can see that that 90 degrees, remember, is kind of like that part of a square. So this is definitely acute, smaller. So all of these measurements are smaller than 90 degrees, so therefore we're going to have to use our protractor to measure it. Okay, so click and drag the protractor. All right. So remember, I'm going to take that center part and put it right on the vertex. Okay, so that's about as good as that's going to get. Then I'm going to have to rotate the protractor so that it lines up along the bottom. All right. Whoop. I guess I should have paid attention when it told me how to make it move, huh? Well, all right, rotate the protractor. Oh, okay, there we go. That's pretty good. And then resize the protractor. Yeah, sure, let's make it a little bigger. Perfect. So therefore we can actually see it. And now we can trace this line up. And what does our angle measure? 30. Perfect. Oh my goodness. Okay. All right, so we'll go a little faster on this next angle. But before I get out my protractor, what type of angle is this one? Notice it's bigger than 90 degrees. Starts with an O,
Obtuse.
obtuse. Thank you, definitely. All right, so here we go. We'll click our protractor. Woo! I'm going to put it down here on the vertex, and then I need to use my keyboard to make it line up along the bottom line. I'm going to resize it so that we can see what we're doing. Perfect. And now notice, maybe I could even make it just a little bigger. There we go. Notice this is bigger than 90 degrees. So you have a choice. Is it going to be the 50-degree measurement? I don't think so. It's going to be, looks like about 133 degrees. I think that would probably be the best choice out of all of these. And Jacob, I just put it on the bottom just because that's just, if you just do it the same way every time, and just line it up with that bottom line of your angle each time, it'll just go easier for you. It's just kind of a habit so that you get in the same routine. And then you always do it the same way, and then you always get the correct answer. Oh, geez. All right. It's pretty funny. Let's do one more and then we'll move on. Oh, geez. Do I even need to get out the protractor for this? What type of angle is this showing?
Right. 90-degree
90
angle.
degrees. It's a right angle. When you see this little square like this, it is a 90-degree or right angle. Oh boy. Okay, well, hopefully that was amusing for you. All right. This actually isn't too bad. Let's just do this last one because this was that funky type of angle called a reflex angle, which is bigger than 180 degrees. So this one is a little bit, it's called a reflex angle, and you can notice that because this half circle is bigger. So let's just practice on the reflex angle because it's a little different. So I have to drag my protractor down. And then I think it's easier if I just resize it right away. There we go. Okay, so then I need to line it up, and I'm going to call this one the bottom line. I think I still need it bigger. Whoa, 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 that's going a little too fast. Okay. There we go. All right. Oh, geez. Good times with protractors. Okay, almost there. Okay, so now, this one's a little harder to see. We have choices. We have a 212, 180 degrees, remember, is a straight line, so we know it's not 180 degrees. We know it's not 148 because that's smaller than 180 degrees. So here are only two possibilities. Let's take a hint.
As you know, there are 360 degrees in a circle. When measuring a reflex angle with a protractor, first measure the acute or obtuse angle.
Oh, yes.
Now subtract this angle measurement from 360 degrees, a full circle. This will give you the measurement of the reflex angle. It's easy.
Cool. All right, so let's turn our little protractor upside down, and we're going to measure the smaller angle and then subtract it from 360. All right. So this is going to be interesting. There we go. It's not quite the fastest thing in the world, but what do you do? Yes, it is. All right, now I need to make it bigger because I can't see. All right, let's good enough. Okay, so this is you have to kind of tilt your head a little bit. It's there we go. It's a little harder to read, but if you had a piece of paper in front of you, it wouldn't be that bad. So, okay, here we go. Let's read this angle, and this smaller angle looks like it's about 148. So now I want you to do the subtraction. 360 minus 148. When you get an answer, type it into the chat. So 360 minus 148. Good job, Jacob. So the only possible answer would be the 212. Cool. All right, so that was pretty fun. I'm going to go ahead and pause this for now. We're going to go back. So we did do a little bit of practice with angles, and you guys helped me measure quite a few angles. We're going to move on. If you want to watch later on, because I sent this all to you and I can send you the agenda again, you could watch a brain pop video on angles. It's pretty cool. It's pretty fun, but it's a little bit easier. So if you want to afterward, go ahead and watch that video. It's pretty cool though. We're going to move on to circles because circles can be a little more complex. Okay. So this is a brain pop video for circles. And here we go.
Do you want one pancake or two? Don't think we have enough batter for 50 pancakes. Dear Tim and Moby, what exactly is a circle and how do you measure one?
Boy.
From Dylan. Circles, eh? Well, Moby, a circle is a little more complicated than a polygon. For one thing, a circle has only one side. In mathematics, it's known as being a closed curve. We define a circle as the set of all points in a plane that are the same distance from one particular point in the plane. Well, that point is called the center. If we know a circle's center, we can measure all sorts of stuff about the circle. Well, I'll show you. The diameter of the circle is the distance across the circle through its center. What's the diameter of your plate? Okay, the diameter of our circle is 26 centimeters. The radius is the distance from the center to any point on the circle. Right, the radius is 1/2 of the diameter, and our radius is 13 centimeters. The circumference of the circle is its perimeter, or the distance around the circle. We can find the circumference by using the formula c equals pi times the diameter. Well, pi is a constant, often represented by this symbol. It's a funny little number, but for some reason it's really useful in measuring circles. As far as we know, it goes on forever, but in most cases it's okay to round it off to 3.14. 3.14 times 26 equals 81.64, and that's our circumference, more or less. If we wanted to get really precise, we could say that the circumference is 26 pi, and leave it at that. Well, the area covered by the circle is known as the disk. We can find the area of the disk with another equation. The formula for area is A, area, equals pi times the radius squared. We plug in our radius and get A equals pi times 13 squared. Order of operations says that we square the 13 first, and 13 squared, or 13 times 13, equals 169. And 169 times 3.14 equals 530.66. If we round to the nearest whole number, that's 531 square centimeters. See the stuff we can learn, armed with just a reasonable approximation of pi and the center of a circle? What do you... Marking the center of the circle. I see. I suppose it's pretty safe to assume that I'm getting blamed for this.
All right. Okay, guys. We are going to take the quiz, and then what I'll do is I'll pull up my sketch pad, and I'm terrible at drawing circles, but I'll do my best. And we will go over all of that new vocabulary that you just learned, and then we will review how to find the circumference of a circle, and we'll review how to find the area of a circle. So let's start here. Good. Okay. Where did it go? Oh, all right. How many sides does a circle have? Well, there are no sides to a circle. It's endless. And what is circumference? Circumference of a circle, I like to think of it as like the perimeter of a circle. It is the outside measurement. And then what is pi? Pi is that little funny number 3.14. So it looks like they don't have like an actual quiz for us, so that's okay. We will go on, and I will pull up my sketch pad, and we'll practice with a few. Okay. So I'm going to get a couple examples pulled up on the screen, and then, all right, Kitty, I'm sorry, you need to move because I need to see where, okay, we're going to B29 in 5th grade. Okay. There we go. All right, so here's our first example. I'm going to go ahead and take a picture of it so that we can, or I can draw on top of it. All right, so let's just review those terms that they went over in the Brain Pop movie. So first of all, obviously, here's a circle. Circumference is, I like to think of it as like the perimeter. So it is the measurement around a circle. Diameter is the measurement through the center of like how far across the entire circle takes. So this diameter, it's kind of small, is 4 centimeters. So that means, here's the center point, this little line segment is only 2, and then this line segment is 2. And that halfway line or halfway point is also called the radius. So radius of this particular circle is 2. Diameter, they already told us, of this entire circle was 4. And so now they want us to find the area. So those are where you have to use those formulas that they told you about. So the area of a circle is pi r squared, and that means multiplying them all together. So remember, pi is just the number 3.14. But order of operation says that we have to do this first. We have to do the radius squared first. So what was my radius? 2. So let's just do that problem first. 2 squared is the same as saying 2 times 2, or 4, right? So now I have to do 3.14 times 4. So I want all of you, it's on your scratch paper, to go ahead and work that problem out. And when you get an answer, type it into the chat. So 3.14 times 4. Good, Josh. I'm going to wait just one more second. I think you just might have added just a little wrong, Jacob, but you were really, really close. So we had 12.56, and there we go. So I'm going to pull up my sketch pad again, and before I go on, I'm just going to review those terms one more time. Okay, so like I said, pretty bad at drawing circles, whatever. Okay, so here is a circle. We need to find a couple different things with this circle, so I'm going to change my color. First one I want to know is circumference. So circumference is the measurement around the entire circle. Think of it as the same thing as like perimeter. So circumference. To find the circumference of a circle, you can use a formula. And I don't know if you caught it in the movie or not, but the formula to find circumference is pi times diameter. Okay? So you need to know what diameter is. So let's go back, change our color. Diameter is the measurement across a circle through the middle point. Okay, so let's just say for this particular circle, to get from this point over to this point, remember that's called diameter, let's just say it's 10. Okay, so from here all the way over to here is 10, a length of 10. I don't care, we could use centimeters, inches, whatever you want, but just 10. Now, halfway, so I'm just gonna, here's my center. If I take half of the diameter, it's just this line, right? So what's half of the diameter?
5.
5, good. And it's a word called radius, okay? So diameter is the entire thing all the way across, or entire length, and radius is half, okay? So let's just take it one step further. We have also the area of a circle, and I'm going to shade it in. The area of the circle is how much space the entire thing takes up. So you need a formula for area. And the area of a circle can be found by saying pi r squared, and that's all multiplication. So if I know diameter and I know radius of a circle, I can find the circumference or the area pretty easily just by plugging in the numbers that I need into the formula. So let's start with circumference of this ugly circle that is now orange. To find the circumference, I'm going to do pi, which is 3.14, times the diameter. So we know the diameter is 10. So you would do your problem, 3.14 times 10, which actually you can do in your head. Anything that's 10 times bigger, you know that you're going to just move the decimal point over one space. But if you want to work out the whole problem, you're going to get the same answer, 31.4. So that's the circumference of this ugly circle. Circumference, just to remind you again, is the distance it takes to go all the way around the circle. Think of it as kind of like the perimeter. So now we can also find the area of a circle just by plugging in what we know, which we know r, into our formula. So to find the area, we know that r in this particular circle is 5, so we would do pi times 5 squared. Okay, so order of operations says that we are going to do anything with an exponent first. And see, Jacob, I just plugged in a 5 where we had the r because I know that my radius was 5. Okay, so 5 squared is 5 times 5, basically. So 5 times 5, everyone?
25.
Good. And yes, Jacob, that is right. If you are multiplying and you're making something 10 times bigger, you're going to move that decimal place to make the number bigger, right? 3.14, to make it bigger, you'd have to move it over one place and make it 31.4. Okay, so now we have pi times 25. So what you would do, and you need to go ahead and just find a little clean space, is set up your problem 3.14 times 25. Go ahead and do that now. Hmm. 3.14 is what pi equals. Okay, so that's why I'm switching this symbol and writing 3.14. So 3.14 times 25, giving you a couple of minutes to work that out. Good job, Joshua. Okay, I think Jacob's almost ready. But once you work out the entire problem, oh, it looks like you added one number wrong, Jacob. You had everything else correct. It actually adds up, and so look back at your work. It actually adds up to 78.5. Okay. All right, so let's just do a quick review. I'm going to draw a new circle. I'm going to draw it bigger this time. That's terrible. Sorry. Okay, so let's just review. If I am trying to measure the length around the circle, type into the chat what that is called. You need to know that vocabulary. If I am measuring the length around a circle, what is that called? And I'm not too concerned about spelling. I just want you to know what it is. The length around a circle is called, starts with a C, circumference. Conference. Yeah, there we go. Okay, and the formula to find circumference, anybody remember? And it's okay if you don't. It's pi times d. Everybody should know this though. What number do we use when we're talking about pi? Go ahead and type that number into the chat. 3.14, perfect. So this is just a and the reason that they use this symbol is because this number 3.14 actually goes on and on and on and on for a really long time. So they can't just call it 3.14 and feel okay about that. So they want to use this symbol pi instead. It's not a huge deal, but just a little side note for you if you're wondering why they would use such a weird looking symbol. Okay, if I am measuring from one side of the circle to the other side of a circle, what is that called? Diameter. Perfect. Okay, so that is represented by the letter D. Diameter. And what it is just one side of the circle to the other going through the middle point. Half of the diameter is called what? Half of the diameter is a word called radius. Okay? So you can see by the color coding in the picture here, radius measures half the length of a circle, diameter measures the length from one side to the other, and then we have different formulas to find circumference, which is the length around a circle, and then last but not least, area of a circle. So let me get a different color. To find the area of the circle, that's how much, think of it as like how much space the circle takes up. Oh boy. And the formula for area, again, is pi, or 3.14, times r squared. Okay? So if you know the radius and diameter, or even if you just know the diameter of a circle, you can find the circumference and the area. Okay, so should we try a couple more on this IXL math? Let's see. Oh, okay, here we go. So here is a new example for us. We know that the radius of this circle that they're showing is 1 foot. Okay, so you can see that there on that purple line. What is the circle's circumference? So let me take a picture of it. Okay, there we go. So let's just review. To find circumference, you need to do pi times d, or diameter. We know the radius, so I need to figure out what the diameter is. If the radius is 1, well, then the diameter has to be 2, because it would be 1 plus 1. So now we have pi times 2. Go ahead and work that problem out, and that will give you the circumference. So when you get an answer, 3.14 times 2, type it into the chat. Perfect. 6.28. Awesome. Let's do one more. Okay. So on this particular circle, they're giving us the diameter. Notice the diameter, Jacob, is from one side all the way to the other side. And the entire length is 28. Okay? So that we know that the radius has to be 14, because it would be 14 plus 14 for the total of 28. Oh, wow, and that was the question. So what is the circle's radius? What's half of 28? Well, there you go. I gave you that answer. Sorry. Okay, let's do the circle's area. So we remember, I'm going to take a picture of this one. Clear, snap a picture. Okay, there we go. So let's just review. The area of a circle can be found by doing pi, which is 3.14, times whatever the radius is squared. Okay, we have the diameter of 2. I know, so this is our last problem. We have a diameter of 2, so that means our radius is 1, because 1 plus 1 would give us the full length of 2. So let's just come over here and plug in 1 for radius. So what's 1 times 1, Jacob? Very good. So what's 3.14 or pi times 1? There you go. Okay, so they gave us a really simple one there, but that's okay. So tell me, Jacob, how are you feeling about all of those terms that you learned today, like circumference, area, or I'm sorry, distance around a circle, area of a circle, diameter, and then radius? How are you feeling about those? Perfect. Well, and just a little bit more practice, and when you get into your Lincoln assignments, you'll have tons of practice. It'll be easy for you. It'll come to you. So I'm glad that that helped out, and it was fun. And I'll see you. Let's see. I guess I'll see you Monday. Okay. All right. Have a good day. Bye.